In this week's lesson, our spies will have the opportunity to explore electricity hands-on. Spies will use their knowledge to create a circuit with a working light and test different materials as conductors or insulators. Electricity is used as a source of power and will only flow when a complete circuit is built. For electricity to get where it's going and do things like light up a bulb, it must be complete. A break in a circuit will cause a stop in the flow of electricity. To begin, we're going to define a few words. First, we have conductors. Conductors are materials that allow electricity to flow. Insulators, on the other hand, are the opposite. They are materials that create resistance and do not allow the flow of electricity. Last, we have current, which is the flow of electric charge creating our circuit. Now we're going to see an example of a completed circuit using something we call our energy ball. When I touch the two prongs with 2 fingers, the circuit is complete and the light glows. When I act as a part of the circuit with 2 other people, and one of us disconnects from the other, the light turns off. The people in our group are acting as conductors for electricity. A conductor allows the electricity to flow. When one of our insulators, or our people, remove themselves from the circle, the flow of electricity stops. Some questions I'd like you to consider, feel free to pause the video and think them over, are: first, how do you think this happened? And second, what changes when only one person stops the connection? In your supplies bag, you'll find all the materials needed for this next experiment, where we're going to build our own circuit with a working battery and a working light. This is what the end product is going to look like, just so you have an idea of what is expected at the end. Keep in mind where I wrote touching and not touching for the wires. To begin, let's turn our SPY manuals to page 4 and very carefully cut out on the dotted line, or the larger square, the circuit we're going to build. Next, we're going to measure out our copper tape and place it along the path on the card. Be sure that if you do choose to cut your copper into pieces, that the individual pieces touch. Peeling off the back can be kind of tricky, so you may need to get some help. It's important for this next part to keep in mind that LED lights have a long and short stem. The long stem needs to be attached to the tape that connects to the positive side of the battery. This is very important. So I pull the prongs apart, and the long side is connected on the right. Once again, we may need a little help peeling off the tape. It can be quite tricky. Then we'll attach the copper wire to the other side of the LED wire. Once everything is in place, we will place the battery's positive side facing down in our circuit. Again, it can be a little tricky to get the battery out of the packaging, so we may need help with this as well. The positive side is going to be with the words on it, and the negative side has more of a pattern. Once we fold our paper, and make sure that the copper tape on both sides is connecting and touching the battery, otherwise your light will not turn on. It might take you a few tries and trial and error before you can get your light to turn on. Sometimes the pressure that you're pressing the battery can be a factor, or making sure the copper wire is touching in all of the corners but not touching by the LED light. So give it a few tries and eventually you will get your light to turn on. A question I would like you to consider while we move on is, how are we, as the person creating the circuit, acting as a switch when we turn the light on and off? As we get into the next part of our experiment, you're going to collect these supplies: the popsicle stick, the fuzzy stem, a paper clip, and some aluminum foil. We're going to cut that part out on the cardboard piece. And notice how once we cut it out, we broke the circuit and it no longer turns the light on. Instead of that piece of paper with the copper tape on it, we're going to try all these different materials. Feel free to search your house and find your own materials to test and see if they are conductors or insulators. Remember that the items that allow electricity to flow are conductors, and items that do not are insulators. We are going to record our findings on page 4. Feel free to add on to page 4 with your own materials around your house that you'd like to test their ability to be an insulator or a conductor. Once you record your own findings, I'd like you to consider these next questions. First, how did we act as a switch in our circuit we made? What surprised you about your circuit, or what surprised you about the different materials you tested? And lastly, what did you notice about the different conductors and insulators? More importantly, what were the materials made of? Were they plastic, rubber, metal? Do you notice a trend with any of these materials and their ability to be conductors or insulators? Alright, that wraps up our first lesson of Spy Camp. I look forward to meeting you again for our next training session. Thank you, Spies!